रेट का ना we'll just do a quick recap. स्क्रीन नजर आ रही है?
Yes. उसे केमिकल एनर्जेटिक्स चैप्टर है ना?
नहीं, रेट ऑफ रिएक्शन, रिएक्शन काइनेटिक्स, रेट ऑफ रिएक्शन, ये केमिकल रिएक्शंस नहीं है उसमें, है ना? उसमें रिडॉक्स एंड रेट ऑफ
नहीं
रिएक्ट,
नहीं।
रिवर्सिबल रिएक्शन एक्सेट्रा। अच्छा, anyways, so I'm just going to quickly do a recap क्योंकि the chapter was like very small, ठीक है? तो what was the rate or speed of reaction? It was, what was it? कि it was, you measure any change with respect to time, ठीक है? How fast some change is happening, ठीक है? And the change could be anything in a reaction. If you want to figure out what's happening in a reaction and how quickly it's happening, you could measure the change in color or the change in mass or the change in volume of gas or the change in concentration or the change in the bubbles of gas being produced, any change that's observable and measurable as well, ठीक है? So rate is, you measure any change with respect to time, ठीक है? And if that change happens quickly, so if
Does
you have the,
these changes tell us how quick the reaction is?
क्या?
ये changes बताते हैं कि कितना quick था reaction.
हाँ, मतलब if the color changes very quickly, that means it's fast, right? Or if the gas gets produced very quickly, then it's a fast reaction. So it's basically any change with respect to time. वो clear है? So for example, if I'm given magnesium plus HCl and it's producing salt plus H2 gas, right? So what can I measure in this? I could measure the change in mass of magnesium because as magnesium reacts, its mass will decrease, right? ठीक है, its mass will decrease. So what I can do is that at regular time intervals, what I can do is I can plot the mass of magnesium. I'm going to take it out after, let's say, every 5 seconds and see how quickly that is changing, right? So the mass of Mg will, normally reactions are fast in the beginning. अच्छा, क्या reason? Why are the reactions faster in the beginning? Zarar, any idea, Taha, Hania? Why are reactions faster in the beginning? कोई idea किसी को?
सर क्या क्वेश्चन है?
Why are reactions faster in the beginning? Normally they're faster in the beginning because there are more reactants. You have more reactants in the beginning, and therefore you're going to have more collisions. So anyways, what you're getting is that the change is happening very quickly. The mass of Mg decreases very quickly, and slowly with time, the reaction starts slowing down because reactants, they start getting used up. So you're always going to get a curve, and the gradient of the curve is or the slope of the curve basically is proportional to the rate of reaction. So steeper the curve, faster is the reaction, okay? And it could be any change. Again, the same magnesium with HCl reaction, right? You could do it in a stop-it container where, let me close the gaps, okay? Make sure when you draw the diagram, it has to be airtight because you're trying to collect a gas. I say anyways. So we're trying to collect a gas. So you've got an Mg that's reacting with HCl, and what you would do is you'll just tilt the apparatus and the Mg will fall into the HCl, and you'll have salt and H2 gas being produced, and there's going to be gas. So there's going to be gas forming, and you're going to measure how quickly that gas forms, volume of H2 gas versus time. So it gets produced very quickly in the beginning. So the stops. There's no more gas being produced. So the steeper the slope or the steeper the gradient, the faster is the reaction. ठीक है? ये clear सांगो ताहा? Yeah, is this clear, Zarar? Ahmed, clear है?
उससे वो थोड़ा नेट इशू है। लास्ट सेंटेंस हमें क्या बोला है, जितना स्टीप होगा उतना तेज होगा।
हाँ ठीक है, the faster the amount of H2 gas is being produced, and then if it becomes flat, that means the reaction has stopped. Uh there's no more gas being produced. ठीक है. The other way of measuring a rate is you keep rate is inversely proportional to time. ठीक है. For example, if इसका example दिया था कि if there's a 100-meter race and there are sprinters running in the Olympics, right? No one measures their speed. What they just measure is the time. ठीक है. They put a mark. Everyone is supposed to reach that mark. Whoever does it quickly, that's the fastest. So this is another way. Instead of plotting a graph, what you can simply do is you can place a marker somewhere. ठीक है. For example, for the same reaction, instead of plotting the graph, you can put a mark over here that this is the amount of H2 gas that should be produced. Now, one reaction produces it in 10 seconds, one reaction produces it in 1 second, one reaction takes 50 seconds. So the fastest is the one that will produce, that did it in 1 second. So you don't have to track or plot an entire graph. What you can simply do is you can just measure the time it takes for a certain change to happen. ठीक है. So instead of plotting the graph and knowing the speed at every time, you just keep change constant and you just measure the time. That's it. ठीक है. Is this clear? Ahmed, Zarar, is this ठीक है? अच्छा, now, अच्छा, and then you had the collision thing, the kinetic particle theory and rate of reaction. Well, reactions happen because collisions happen between particles. If there were no collisions happening, you wouldn't have a reaction. You need collisions to happen so that old bonds get broken and you can form new bonds because the old bonds are very strong, so they have to collide with something. And so that, like, if I have a phone, I'm going to throw it in the wall, the old bonds in the phone are going to get broken. And then there's a chance that you can make something else. It's going to break down into pieces, and then you can sort of maybe try and make something else out of it. So the old bonds have to be broken for a reaction to happen. So it always happens because of collisions, and so rate depends on two things when you talk about collisions. It depends on the frequency of collisions, which is the number of collisions that are happening, and the effectiveness, how strongly are the particles colliding. Both are two different things. Frequency is the number of times they collide, and effectiveness is how strongly do they collide. ठीक है. So there are five factors. Temperature. What does temperature do? A higher temperature leads to more kinetic energy. And if you have more kinetic energy, what you get? You get more frequent because particles are traveling more quickly. And you also get more effective collisions because they're traveling quickly. They will bump into each other with a lot more force. So you're going to get an increase in effectiveness and an increase in the frequency of collisions with temperature. With pressure, what happens is that when you compress something, the particles they become closer to each other. And when they become closer to each other, they're going to bump into each other more frequently. So with pressure, what happens is the volume decreases and particles are closer to each other and you get more frequent collisions basically. But the proportion or the percentage of effective collisions would not change. The concentration is something similar. It's in solutions. More concentration means particles are closer to each other. They're going to bump into each other with a lot more now. So again, what you're going to have is more frequent collisions, but the percentage of effective collisions will not change. The collisions are not becoming more energetic, only that you will have more of them because all of them are closer to each other. ठीक है? Or catalyst, what does it do? It reduces activation energy. Basically, what it does is that it makes the reaction easier to happen. It weakens the old bonds. So the old bonds, they break very easily.
सही क्वेश्चन है सर।
हाँ जी।
सर जितनी ज्यादा एक्टिवेशन एनर्जी होगी उतनी ज्यादा लाइक टाइम लगेगा किसी भी रिएक्शन को हैपन करने में, राइट? क्योंकि वो
हाँ
एनर्जी रीच करने में टाइम लगता है ना।
हाँ, बट टाइम नहीं, अगर तो एनर्जी है ही नहीं तो ऑब्वियसली दैट रिएक्शन विल नेवर हैपन ना।
देख अगर
जिस
एक्सोथर्मिक एंडोथर्मिक जाने तब भी तो लाइक वो चैप्टर भी रहता है ना सर हमारा।
हाँ वो रहते, वो भी एक ही क्लास में हो जाएगा। मैं वैसे कह रहा हूँ, फॉर एग्जाम्पल एन ट्रिपल बॉन्ड एंड ना, तो इट वुड रिक्वायर अ लॉट ऑफ एनर्जी फॉर दिस बॉन्ड टू ब्रेक. So if the bond doesn't break, so you won't have any reaction. ठीक है? So you would require a lot of energy for the bond to be broken. ठीक है? तो catalyst, what
नहीं
is
सर
it?
वैसे मैं एक सवाल है वैसे कि एक्टिवेशन एनर्जी करती क्या है लाइक वैसे।
करती कुछ नहीं है, मतलब ये मॉलिक्यूल है ना, एन ट्रिपल बॉन्ड एन, right? And there's this molecule H2, right? अच्छा, both these molecules, they have to collide with each other, right? अब this will be traveling this and there will be a collision between the two. अब it's if both molecules have very less energy, so they will collide with each other very, very slowly. तो उसमें तो कुछ भी नहीं होगा, उसमें the only thing that will happen is कि it's going to collide and bump and would travel somewhere else, right? Clear है, बात समझ आइए? So you won't have a reaction, right? Is that clear?
यस सर।
The other is you increase temperature, right? You give it a lot of energy. So now these particles, they travel quickly and this comes flying in and they bump into each other and they bump with enough force. Okay, the molecule and the bond, uh, they split into two. Sorry to get एक second. Acha, and they go flying apart in different directions. Or the other one also breaks into. ठीक है, so the old bonds have now been broken. So yeah, activation energy. It's so every reaction requires a minimum amount of energy so that the old bonds have to be broken. अब new bonds बन सकते हैं ना, right? This N can go and it can maybe bond with H. So something new could be formed, right? Is this clear?
जी
So,
सर।
so activation energy, जो है ना, that's the minimum energy. For example, if you want to burn a match, you have to strike it or you have to put it in heat, some fire, because there is some amount of energy that is required because the match has bonds which are very strong. They have to be broken. वो जब strike करते हो ना, that's when its old bonds get broken. There has to be a collision or there has to be a very high temperature so that the old bonds, they break. And then it can form new bonds with the oxygen that's in the air. Is that clear?
यस सर।
Achha, anyway, so activation energy is the minimum energy that's needed to at least break the old bonds. ठीक है? तो जैसे आपका, let's say there's a table, right? It's मतलब my laptop is on a wooden table. But table doesn't burn, although there is oxygen right around it, right? तो draw कर लेते हैं ना कि now theoretically the table should burn. Let's say this is my table, right? And there's an oxygen gas molecule everywhere around it. So the problem is that the oxygen gas molecule is traveling so slowly that it just gently touches and bounces back from the table. None of the old bonds get broken. I said, like when it's a high temperature, if you put fire next to the table will catch fire. So what happens in that case, the oxygen gas molecule becomes very energetic, right? It starts traveling very quickly and it strikes the table with a lot of force. And when it does that, all the old bonds, even in the table, whatever the atoms are in the table, they all break, right? And now it's capable of forming new bonds. Well, maybe there's a carbon atom that broke off from the table during that collision, and now they can form carbon dioxide. When carbon dioxide gets formed, okay, now they can form bonds. That produces a lot of energy. Okay, that's what combustion is. So idea clear about that's there's a certain amount of energy that's required to start a reaction. Otherwise, the reaction will not start. Is that clear? Is that clear?
Yes, sir.
Taha, is this
Yes.
Bakiyon clear? Ahmed? I just that is activation energy. So certain reactions have very, very high activation energy. But for example, you've got an iron chair, right? I'm sitting on an iron chair. That will not burn. Why would it not burn? Because the metallic bonds inside the iron are very strong. They don't break. So if they don't break, they don't form new bonds with other things because the old bonds haven't broken. So which is why, so that means if you want to burn iron, that would probably require a very high activation energy. I mean, you can theoretically burn iron, but it would require very, very extremely high temperatures. Okay? So certain reactions have very high activation energy and they're very hard to happen. Reactions that have low activation energy, they happen very, very quickly. So it's the amount of energy that's needed to start a reaction. What does a catalyst do? Okay? So what a catalyst does is that it reduces the activation energy. It makes it easier for the bonds to break. मैं example दे देता हूँ कि although the detail is not required, there's a reaction that we're going to study later on as well. That's the Haber process. The whole problem with making ammonia is that the N triple bond and the H2, even if they collide, the N triple bond is so strong, it's one of the strongest bonds, that this bond, it simply does not break. It's one of the strongest bonds and it doesn't break. So you don't get a reaction. They just keep bouncing off each other and there's absolutely no reaction. Really difficult to break this. I said, but what a catalyst would do is if you put a catalyst like iron, normally what catalysts do is that they weaken the bond. So what a catalyst in this case would do is that it will, maybe due to attraction, it will start to weaken because the electrons being shared, right? So what it does is that it sort of applies a force and weakens this bond. So it becomes easier to actually break it. And so that is the purpose of a catalyst. It just makes it easier to break the bond. So you don't need very high temperatures. You don't need very high activation energy in this case. ठीक है, clear है?